In this example, we're going to apply what we know about sign charts and what they tell us about functions and apply it to a profit question. So in this example, we say that if the revenue from the production and sale of X number of items is given by the function R of X is equal to 140X minus 0.5X squared, and the total cost of producing X units is given by C of X is equal to X squared plus 20X plus 1050, determine the interval or intervals on which the profit function is increasing. So the things to keep in mind is what we want to know is we want to know where the profit function is increasing. So we need to know what the profit function is. Remember, our profit function is always given by our revenue function minus our cost function. And we're given both the revenue and the cost function in this case. So our revenue function is 140x minus 0.5x squared. And I'm subtracting from that my cost function. Now notice you have to put the cost function in parentheses because the negative of the subtraction is going to apply to every term in your cost function. So in order to combine these two together into one single polynomial, I'm going to change my negative to a plus outside the fraction, or outside of the parentheses, I'm sorry. And then I'm going to change the sign for each of my three terms here. So what I wind up with is 140x minus 0.5x squared minus x squared minus 20x minus 1050. Okay. Now I can go ahead and I can put like terms together. So I can put together the negative 0.5x squared minus x squared. So this is going to be negative 1.5x squared. And then the 140x minus 20x is going to be plus 120x. And then minus 1050. So this is my profit function. So in order to tell where my profit function is increasing, I need to know what the derivative is. So if I take the derivative of my profit function, I'm going to have negative 1.5 times 2x to the 2 minus 1 plus 120 times 1 times x to the 1 minus 1, and then negative 1050 is a constant, so that derivative is always 0. So the derivative of my profit function is going to be negative 3x plus 120. So there's my derivative. Now I can look for my critical values. So I'm going to go ahead and set negative 3x plus 120 equal to 0. And then I just solve for x. So negative 3x is equal to negative 120. Divide both sides by negative 3. And x equals 40 is my critical value. So this is my critical value. All right. So with that in mind, I can go about making my sign chart. The only value that I have, I've only got one critical value. It is 40. So I'm going to fill in that circle. Now I'm going to take a look at what my what values I'm going to go ahead and choose. So the thing to keep in mind is that in this case, in this example, X represents the number of items I'm selling. So I can't sell a negative number of items, right? So my function really, instead of kind of being the entire number line, it ends right here at 0. But then the number of items can increase beyond there. So with that in mind, I'm going to pick a number between 0 and 40 for my first interval. And that I'll pick as 1. And for 40 and above, I'm going to pick 50 as something relatively easy to go ahead and calculate. So if I take p prime of 1, so that's negative 3 times 1 plus 120. So that's going to be 120 minus 3, which is going to be 117, which is positive. So I know that my function is increasing, okay, on the interval 0 to 40. Now I'm going to go ahead and evaluate my function or my derivative at 50. So I have negative 3 times 50 plus 120. Well, that equals negative 150 plus 120, which is going to equal negative 30. So that's a negative value. So I know that the derivative is negative in the right interval, and my function is decreasing when x is greater than 40. So with this in mind, I know that my profit, to answer the question, is increasing on the interval 0 to 40. And remember, I can't go all the way to negative infinity because x represents the number of items sold, and that has to be positive. But I know that my profit is increasing as long as I am selling between 0 and 40 products.